to introduce himself once again and talk about the research he did.
Okay. Thank you, Paolo, for the invitation and for the kind introduction. I will share my screen and I will introduce myself from there. And then to put one. Hope we can see it in full screen or not. Hope we can see my screen.
Yep.
Okay, super. Yep. So second time, my name is Ahmad Beit. I work as a professor at the University of Southern Denmark, and I'm leading a new section in digital and high frequency electronics. I also coordinate two large-scale research projects, one under Horizon 2020, which is an European project in which I get to know Paolo and IIIAAC, the project called Drones for Safety, and the national project called Drones for Energy. Today I will give you the outlines of these projects that enables us to build drones for inspecting infrastructure parts and also recharge from overhead power lines. Just for your orientation, University of Southern Denmark, we located in Denmark in 5 different cities. The biggest we have is in Odense, in which I am located. The department is in the one in the bottom here. This is a faculty of engineering, and then we have others in different locations. Around 30,000 students are studying at the University of Southern Denmark, and 3,000 of them are studying engineering. And we offer bachelor and master degree education, robotics, digital electronics, software engineering, and so on. This is my research team, 3 PhD students and 2 assistants. And we work mainly in building drones. I have a background in electronics and embedded systems, and the team is doing work related to that as well. So our strongest part is to build an autonomous drone system that can do activities related to power lines. So how we can track the cable autonomously, how we can touch the cable, how to recharge from the cable, and also how to mitigate electromagnetic interference. Yeah, and that will be my agenda of today. So I'll give you the outlook of these projects and also how we build the drones, what kind of technology we use, how we mitigate electromagnetic interference, and how we charge. I started this journey in 2017. I was actually watching this video when I moved to SDU. This is from the American grid. This is an inspector. He is, you can see from his badge on the hand. And his task is to make an inspection of the power lines. But he was doing something interesting to me. It was like moving from a helicopter to the line. And you can see there is an electric arc now will appear because his body was not in the same voltage level as the power line. But he's wearing a nice jacket and he can doing a physical inspection. His hands and eyes looking for defects. So quite interesting. And also I watch it to other countries, more or less they do the same. So we had a new project idea called Drones for Energy, using drones to change this situation. It is a large project, so we got funding from the Danish government by 3 million euro, a little bit large in dollar. And that is to enable us building an autonomous drone system that can fly along the power line and benefiting from the high voltage line to recharge. So we can combine energy harvesting, swarm system with AI to build this technology. We took that to the national, the international level, speak here about the European level, and we said, can we apply this to inspect also railways and bridges? And here we have the teaming up with other partners around Europe to build this project. And here we had another funding was around 3.7 million euro to do more activities to make inspection of other parts of the infrastructures. Yeah, so we can basically charge from high voltage line, flying towards a bridge, looking for defects in the bridge, and then come back to recharge, or doing the same with railways. And when we look to the data in Europe, I can get the laser pointer. Yeah, we can see like within 3 kilometers, we can reach up to 70% of bridges. So we can see futuristic drone fly for 20 kilometers that can charge, fly 3 kilometers, taking some pictures, come back to recharge, and going back and forth until it finish bigger parts of the bridge infrastructure. Or it can also doing the same with railways. And also we are building a system to recharge from the railway lines. We had two options in 2017 is to use classic commercial drones, DJI drones basically, or to build things from scratch. Since we are engineers, we like to see everything in the system, so we built everything from scratch. We used a previously developed European flight controller called Bixhawk with a BX4 flight stack to build the drone system. And then we worked in the autonomy part using onboard computers connected with special sensors to steer the drone, and we built control algorithm on the high-level computers. And here we used classic CPUs, also GPUs, but also use FPGAs to accelerate the task on board the drone. And we use ROS to facilitate the interactions between the sensors and actuators. And we use the same between the drone-to-drone communication and also sending the data to the cloud. Big advantage is this open source, so we can see everything, and it is made in Europe, so we also know where is our data and everything kind of under our control. And we have many prototypes, and this is one of them. It's a small drone, less than a kilogram, with a camera and a millimeter wave radar to see the power lines, and also onboard computer. Yeah, with the classic stuff like GPS and flight controller and so on. Sorry. Yeah, and
I see the RGB camera on top, but I'm guessing there's also a camera on the bottom to do the actual inspection.
Yeah, we add also camera on the bottom. Here is only for tracking the cables, but then when it comes towards an inspection, I will show it to you in the next slides, where we add our units basically. Yeah. For everyone's orientation, the footnote in the bottom, it is a research article that one can read to know more about this specific topic, like how we build the system and also what kind of sensors are there, and also what one can add as an attachment. Yeah, and here when we look to the hardware, I can see like majority are using CPUs, which can do okay work, lower performance, but also takes less time to develop. GPUs takes more time, but also giving a higher performance. FPGAs takes more time, but the highest in the performance ever. And it's usually used in space applications, so we are bringing them to drones. Yeah, we have a design, like a drone is basically developed and tested around the power line. And that is one of the designs. Yeah, we test in simulation to be sure that everything is all right. We have a model of the power lines, and we can see here the drone can see the 4 cables, the 3-phase plus the ground one on the top, the earth cable. Yeah, and then we take the drone here in a manual flight test to see what it can see. So this is what you see from the camera, and the point you can see, these are the millimeter wave data, and then we will make a sensor fusion to improve the accuracy, and we can like in like we have an accuracy of ±2 centimeters, so we can be very precise estimating the cable position, like X, Y, Z of each line. I think the video should move, but I have a little issue here. Can see if I can accelerate this one. Okay, it was a bit faster.
And you mentioned that the detection of the power lines is not just with RGB, it's with radar.
Yes. We use only the camera to know the orientation of the line, like where it is heading, right, left. Like not, yeah. So it's basically we use Hof transform to know that if the line is moving, yeah, which direction, so we can yaw the drone towards the line. I have a little issue with the video here. I'm sorry about that, but I will move forward, and then maybe there is another video can give you the idea. Putting that all in a drone, so the drone with the sensors can detect the line. You can see here the drone is flying autonomously. And we have the camera now in front, and then here we run the YOLO neural network to detect the component, and if there is any defect, so can tell us there is an issue here. So we covered one of the insulators, and the drone can say there is a defected part, and then when the drone finishes the mission, it goes to the middle of the line and does a recharge landing. So first here we do grasping in that mode, in this design, and then we do energy harvesting using a split core current transformer. The drone shuts down the engines, like the motors, and then it stays 2 hours and 40 minutes to charge 10 amp hour battery. And this lets the drone fly for another 20 minutes. Of course, with the battery now are getting better, and we are optimizing the harvester, so we can fly a little bit longer and also charge in a shorter time. So from our today's result, we can charge in 1 hour and a half instead of 2 hours and 40 minutes. So we are lowering the charging time.
And what's the runtime? Is it 20 minutes?
Around 20 minutes for this big
okay.
design. Here we don't. This drone is huge drone, like 12 kilogram drone. It's a so it's a research drone, but we are optimizing this in a smaller version, like the one you see here. But the small one, it has only the sensor, but we are also making some optimization a little bit larger and adding also the energy harvester to get the right balance between the component. And then the last part here is the electromagnetic interference. So what will happen to the drone when it will touch the high voltage line? So we went in the street. Of course, we got the permission from the energy company, and we touched 150 kilovolt, which by the drone is shielded using a Faraday cage. So you can see the drone is look a bit strange here. And then we said, okay, let's try to hit 400 kilovolt. But that was not good. So the drone collapsed here. And then we understood there was some issues with our Faraday cage. There were a lot of gaps, so we protect, and you can see now the drone is absorbing the electric arc, and the drone's electronics are protected, and the drone is quite stable around the line. Yeah, and then the part here is about the energy harvesting. Just to give you a quick, I'm not entering into equations, but I can tell you a little bit about what we do. There is a material here, and here we use special types of material like ferrite, or there are more expensive ones that can efficiently direct the magnetic flux around the core. We make a lot of studies to find the best material and how to adjust this to fit the amount of magnetic field is produced by the line. And then we build different circuits in order to charge the drone battery. So we have a AC to DC converter, and then something called maximum power point tracking to check that the battery voltage is all right with the energy, the harvested energy. And then we also added a wireless charging unit. I will explain to you why is this. And then we have an energy harvester here. Why this is important? Because we thought also instead of carrying the energy harvester, we can also put it in a charging station. So you can see here, it's a design in which the energy harvester is a part of the charging station. So the circle here around the cable is a split core current transformer. On the bottom, we have kind of a shaft. So with a robotic end effector, like some motors, can spin and then close the core. And then on the top, we have the wireless pad, so the drone can land and recharge. How we can mount this? We have the robotic arm with a bigger drone, so that can lift the charging station and mount it on the line. And this is also like the drone first hook on the line, move the arm, mount it to the line, and leave the charging station. Yeah, and here we have some testing. This is our own small setup. That's why the guy here is near the cable. And here he was flying manually the drone to try to land it. Here I want just to show you the idea. It was a bit windy that day. You can see it was snowy also. It was very difficult for him to land. But our plan is to make it using special types of code so that the drone also land autonomously on this charging station. And then we make some improvement. We understood also when we grasp on the line using the energy harvester, the core became magnetized and it needs a lot of energy to open it. So we said, okay, we can also optimize the core a little, so we can also save some weight. And we make some analysis to make the stress test, like a tensile test. So to try to pull the sides and applying the magnetic field in the middle. And then we can see here we have a lot of newtons to, for example, when we passed 500 amp, we need 300 newtons to open this. That is too bad, too heavy. And here we make the study and try to open the core using this machine. By also here we kind of simulate how much current could be in the line, and in that case we passed around 1000 amp, and we can see here the machine wanted applied around 450 newtons in order to open it. So it's difficult. But this is also good for us because we can use this huge magnetic force to keep the drone on the line. So this is another level of optimization if you can catch what I'm trying to say. So we remove there was a gripper first, so we can now here we use only the drone, and it is stiff enough to stay in the line. The other challenge is how to open it. It's quite difficult to open. So we have to work a lot with the electronics in order to regenerate the magnetic field inside and open this core. Yeah, and then we went to the street again. And then we have the drone, and then we have the charging unit, and then we grasp on the line. We recharge, then we open the core, and then we leave. We left the line. That was quite also risky here. We got a lot of permissions from the energy company before we do this test, because the high risk here that the drone will stay forever. Nobody can create this 400 newtons to open the core. But that was first time in the world to be done like this, and we were quite proud of the results. And it came in different media to say about this big achievement. I think it happened last year in June, May time.
Curious, how many different power companies did you approach, and what was the process of getting them to okay such a thing? I would imagine that there would be a lot of questions and safety concerns. So curious how you overcame that.
Yeah, it's a long journey. So we started in 2017. I have a very close connection with a state company in Denmark. So we built up with them a trust level. We have a lot of also agreements with them. And then we took it step by step. first thing we touched the line. It was like 3 years ago, and then we asked always for something a little more. They trust on us, so we trust on them, and then they say if something goes wrong, nothing will happen to the line because they see the drone, they check it quite carefully, but they said the drone will not come back to you. So they were worried about us that we will lose the drone. For us, it was a bit of the opposite. Like, okay, I was worried about the line. Yeah, but in Denmark, I would say it's innovation country, so things are a little bit open. So with some good discussion and the agreements are clear, so we could do that. And the energy company could see a huge benefit of doing this. And in Denmark, always the energy company want to be on the top of the market by applying new research ideas. Yeah, so we can keep up. The line can be always checked, and also the energy company can show that there is new technology also is applied to the grid. Yeah, but it's not easy. Like in Italy, we were not allowed to touch the line. So that's another story. But because we don't really know them, like we are not too close to an Italian energy company, for example. Yeah, but as you know, like we are engineers, so we understand the risk. I know, like nothing will happen to the line. What will go wrong? Like, it's a cable, has some current. Worst case scenario, the drone will stuck, or that's it. Yeah, but
yeah, agreed. I can't see the drone for some reason, damaging the line or causing the conductor to fall. But to your earlier comment, in terms of Italy and not knowing, I think this is pretty innovative, pretty awesome stuff. But to get utilities on board and move away from the rule of no touching the line, I could see that as a challenge. But this is pretty cool stuff.
Yeah, I agree with you. Each time I present, then I got the same, like how it comes. That's because we are in Denmark. It's different. I think if we are in another place, that could be quite difficult. Yeah, we also, I think we are the only research institute in the world that we have our own power lines, and we have also our own designated area for flying drones that they are coming together, so we can fly drones in a restricted space with power lines. So we have a lot of rapid testing. Like we test a lot of technologies and we prove that this work. Then we can move to the next step. Okay. Yeah. I mean, I see if you see the videos and so on, so you can go to this website if you would like to get this research papers. sdu.dk/DIII. And if you have any question, you can send it to me. This is the first letter of my name. And then at sdu.dk. Okay. Thank you, and I will stop sharing. And if you have questions, please ask.